In this problem, on the topic of Newton's laws of motion, we are told that two snowcats are being used to tow a housing unit due north. The sum of the forces, as we can see in the diagram, Fa and Fb exerted on the unit by the horizontal cables is north and is parallel to the line L. If we are given the magnitude of Fa to be 4,500 newtons, we want to find the magnitude of Fb and the magnitude of Fa plus Fb. So we'll choose the y direction to be forward for the motion of the snowcats, since that coincides with the north, and x to be to the right on the diagram as it is in the textbook. So since the housing unit moves in the forward direction on a straight line, there's no acceleration in the x direction. And so the net force in the x direction has to be 0. So writing the equation for Newton's law along the horizontal direction, we have the resultant force in the x direction must be the sum of that due to force A plus the x component of the force B. And this must be a total of 0. So using some geometry, this is the horizontal component of a Fa sine of 48 degrees minus Fa sine of 48 degrees plus Fb sine of 32 degrees, and this must equal to 0, which means from here that since we know Fa, we can rearrange and solve for Fb. So Fb, with some mathematics, is Fa times the sine of 48 degrees over the sine of 32 degrees. Substituting our values in, we get this to be 4,500 newtons times the sine of 48 degrees over the sine of 32 degrees, which gives us the magnitude of Fb to be 6,311 newtons, or to two significant figures, 6,300 newtons. And so that's the magnitude of force B. Now, since the x components add to 0, the magnitude of the vector sum of the two forces will just be the sum of the y components. And so the sum of all the y components of each force, Fy, is equal to the y component of A, Fay, plus the y component of B, Fby. The y component of A is Fa cosine 38 degrees, or 48 degrees rather, plus the y component of B, which is Fb cosine of 32 degrees. So this is 4,500 newtons times the cosine of 48 degrees plus Fb, which is 6,311 newtons times the cosine of 32 degrees. And so calculating, we get the sum of the two forces to have a magnitude of 8,363 newtons, or to the correct significant figures, 8,400 newtons.